Welcome. Today's lesson is over section 10.7b. We'll still be talking about partial fraction decomposition, but here we'll be talking about it when you have repeated linear factors. So before, you had all different factors in the denominator. This time you'll have ones that are actually the same. So if you notice, x minus 1 to the third you've got 3 of them. So I will need to write those with first it to the first power, so x minus 1. Then I need to continue writing that denominator over and over again until I get to the highest power. So here I write x minus 1 squared, and I'll have an x minus 1 cubed. So if we were to have something to the fifth, I'll have 1 to the first, to the second, to the third, to the fourth, to the fifth, all the way up there. Now notice x is not repeated, so it gets its own fraction still, but I'm only going to write one fraction to represent it. But then from there, the process is exactly the same as what we did with just distinct linear factors. So I'm going to multiply both sides by a common denominator, which is x times x minus 1 cubed in this case. Then from there, I can get the following equation. Now I want to be able to multiply those factors through, so multiplying them out. So x minus 1 cubed will end up being x cubed minus 3x squared plus 3x minus 1. Then x minus 1 squared times x would be x cubed minus 2x squared plus x. From there, I can multiply the a, b, and c, and d all the way through the parentheses to get the following equation on the right side. And then from there, I want to group them, just like we've done before. So I'll put all the cubes in a group, all the squares, and all the x's, and all the terms that do not have an x attached to them. Now from here, we will factor out the x cubes, the x squareds, and the x's from the parentheses that we've created. Now because I'm missing some terms, I expanded the left side to include the terms that I don't have. So since I don't have an x cubed term, I'll write 0x cubed so that I know that that value should be 0. Same thing with the x. I don't have one, so I'll write 0x there. And so then now I can be able to represent all my equations correctly, given both sides are equivalent. And then once I have the following equations, I can go ahead and solve. So the last one, I get negative a equals 1, so I can solve that pretty easily by dividing by negative 1 to get a. Then from there, I can find b, which is 1. And then because I have a and b, I can go ahead and find c using the second equation. So therefore, c is 0. And then to find d, I will use all three of my values with the third equation to help me find that value. And it looks like d will be 2. So once I've had all my values solved for, I'll go back to the top and plug them in to figure out what my partial fraction decomposition will look like. And then I get the following answer. For letter B, I'll do the same thing. Now notice I have an x minus 1, so that'll get its own fraction. Because I have an x plus 2 squared, I'm going to have a fraction where it's just x plus 2, and then another fraction where it's x plus 2 squared, since that's the highest degree for this. And then from there, just like the last one, I'll multiply both sides by a common denominator, and then cancel out what's left, so then I can have the following equation. Multiply those binomials out as best as I can. The last one doesn't have a binomial to multiply to, so I'll just multiply the c through. Then once I've done that, I can multiply the a and the b through to their parentheses. And then I can group them, putting the x squareds, the x's, and the terms with no x together. And then factor out my x squareds and my x's. Notice on the left side I don't have an x squared term, so I'll write in a 0x squared so that I know what that value represents for my equations. And then I can set up my 3 equations. For this one, because the bottom 2 equations are set up nicely to get rid of c, and the top equation's already just a and b, I'll actually add those two to get an equation where I can put those 2 equations together, and the a and b's, or the b's, are set up nicely to be canceled out when I just add. So then I get the following answer. Now notice it is a fraction. Sometimes it will be this way, and that's okay. All right, so it'll just look a little funny. So here I get a is equal to 4/9. And then I have to go back and find what b is. Notice that I have to make common denominators here to find what b is. So that'll be negative 36/9. And that allows me to get a value of negative 4/9 for b. And now we can plug in both those values to help us find c into one of the bottom 2 equations. It looks like I picked the second. Okay, I'm going to reduce that fraction of 12/9 to 4/3. And then I'll have to subtract to the other side to get 5/9 for c. Now here, because they're fractions, I'll start by doing the same thing that I've done before, and I'll plug them into their positions in our fractions on the right side. But because there are fractions, that makes them complex fractions on the right side. So for a correct answer, we need to simplify these a little bit. And what we actually do is the bottom is our denominator. So it's almost like it's x minus 1 over 1 and x plus 2 over 1. So we actually can multiply by the reciprocal, which makes the first fraction 4 over 9 times x minus 1. Same thing with the next one, negative 4 over 9 times x plus 2, and 5 over 3 times x plus 2 squared. And then that would be our following answer because of that. Okay? Thanks for watching.